Hi, I'm Blake from networkingexamacademy.com, and today I'm going to show you how the spanning tree protocol works. So let's begin. Here, my little notepad, we talk about the spanning tree protocol, or for short, STP. So here we have three switches like you would see in a switch rack. And this is actually an example that I did when I worked for a voice over IP phone company for one of our customers. So they had three switches in the rack, and we're not going to worry about VLANs or anything today, but they were all joined. So A connects to B, and then B connect to C. But it's also good to have redundant links. So we're also going to connect A all the way down to C. That way, if, for example, this connection here goes bad, computers from switch B can still access switch A through switch C. Now, the problem with switches is that frames that get forwarded don't have a way to detect loops on their own. And frames can actually end up looping around in here forever infinity and can bog down the network. So something was invented, STP, to prevent loops. So there's pretty much three steps that STP uses to figure out which links it can turn off in order to logically break the loop. That way, if it could, for example, turn off one of the links, that way it will stop the loop, but it can turn the link back on in case another route goes down, and it can be used to continue to forward traffic. So we're going to talk about this process. So the first step is that STP is going to elect a root bridge. Now, we use the term bridges when we talk about STP because STP was originally invented to work with bridges, but bridges are no longer used in networks pretty much, so now they're known as switches. And so when I say bridge, I pretty much mean a switch. So to elect the root bridge, STP uses what's called a bridge ID, or a bid. And a bid consists of two parts. It's 8 bytes. The first part is the bridge priority. And that is 2 bytes. And that consists of this first half, this first part here. And by default, the number is 32768. But it ranges from anywhere from 0 to 65,535. So this is the default bridge ID, or bridge priority. And the second part is simply the MAC address, which is 6 bytes. So in this case, when the bridge priorities are all the same, you will use the lowest MAC address. In this case, it's the MAC address of router A, or switch A. So switch A, because it has the lowest bid, becomes now the root bridge. Now these bridges are going to talk to each other and do this whole election process by sending what are called bridge priority data units, BPDUs. And they are sent out by default every 2 seconds. So they're communicating, sending these bridge PDUs, and they elect the root bridge. Now the second step is to elect the root ports on non-root bridges. Yeah, when I first was learning, I thought the root ports would be on the root bridge, but root ports are on the non-root bridge. non-root bridges. For example, B and C are non-root bridges. So it needs to elect root ports, which is the lowest cost route. So let's just say these each have a cost of 4 because they're gigabit links. You don't really need to know how the cost is determined for the ICD-1 exam, I don't think. But so right now we'll just say those are cost of 4 because they're gigabit links. And so this port right here on switch B is going to be the root port. So that's the root port for switch B, and then the root port for switch C is going to be right there, because it has the lowest cost to the root bridge. Same here. So now that we have the root bridge, we have the root port selected from the non-root bridges, we are now going to select the designated ports on each LAN segment, or each switch segment. So this is a segment, and connection from C to A is a segment. So step 3 is or select designated ports. So same way, we're going to use the lowest cost path to the root bridge. So the root bridge, every connection from the root bridge is going to be the designated port because it's the lowest cost. So the designated port, what it does is it is the only port on the LAN segment that can forward and receive frames. So this right here is going to be the designated port, DP for short. And then this link right here as well is also going to be the designated port because it's on the root bridge. So now if we look here, so we have this LAN segment left, which does not have a designated port. We're going to pick this route because it has the lowest cost. So now that we have the root bridge, the root ports, and the designated ports, what STP can do now is it actually turn off every other port and put it in a blocking state. So it's going to turn this one off, and frames will not be forwarded or sent out this port. Basically, it breaks the loop. And if, for example, another link goes out, what happens is this can automatically be turned on and the connection can be brought back. But because it turned this off, loops will not occur in this switch setup. So that's basically how the STP election takes place. And to learn more about STP and other networking topics, please visit my website at www.networkingexamacademy.com. Thanks.